Welcome back. It's time to get some hands-on experience with Blueprint. Now, as mentioned in the previous video, there are two kinds of blueprints. There are blueprint classes and there are level blueprints. Now, we're in a level. I'm in my basic map, and the basic map is a level, so it has its own level blueprint. We can access that with this icon. It's a drop-down. We can expand it, and the way to open the level blueprint is by selecting Open Level Blueprint. Let's go ahead and click on that. Now, this is what a blueprint looks like. Now, the largest panel in this editor is the event graph. This is where we do all of our visual scripting using nodes. We can right-click and move around in the event graph, and we can use our mouse wheel to scroll in and out, to zoom. We also have a My Blueprint panel, and you can see under Graphs, there's an Event Graph dropdown, and this shows us which nodes exist in the event graph. By default, we have these two nodes. They're not being used, so they're kind of grayed out, as you can see, but these are two very, very commonly used nodes in just about all blueprints, so they're kind of just placed there for us automatically. Now, to the right, we have the Details panel. The Details panel is always context sensitive. It usually shows us details pertaining to whatever we have selected. Now, the easiest way to get started scripting is by creating some nodes, and one of the most important nodes that you can use when developing is the print string node. Notice that our event graph says right-click to create new nodes. This is why it's much easier to script out functionality more quickly in Blueprint than it is in C++, because we can simply right-click and choose from among the nodes available in order to start scripting some behavior. And the search bar allows us to find things even more quickly. We're going to search for print, and what I'm interested in is print string. If we click on that, we get a new node. Notice it says development only. That's because this print string is designed to be used when developing games, but not for a final packaged game that you ship. Now, nodes can have input pins that take in data, and any data that you pass into a node has its own data type. A string is a series of characters. So this input, called inString, has the string data type, and we can hook up wires to input pins to feed data in, but in the case of a string, we can also simply type in the data. So we can click on the text box and we can change the default text. By default, it says hello. Now, we've added a print string node to our graph, but notice that the print string node has input and output execution pins, and we don't have anything hooked up to them, but you may have been tempted to come on over to the begin play node and click and drag on its execution pin and get this wire and hook it on up to the print string node. As soon as we've done that, we've now connected print string to event begin play. Event begin play is a starting point for Blueprint logic to begin executing. Begin play is executed when the game starts. In other words, when we press the play button. Begin play is executed once, right away, at least for the level blueprint. So we've now created our very first blueprint script using the print string node. Now, I bet you can guess what print string does. We're going to see some text on our screen. But let's test that theory. We can go back to the basic map and start a Pi session, and as soon as we do, I want you to keep your eye on the upper left corner of the viewport. Ready? Let's click play. There it is. We see hello. Now, it only lasted for 2 seconds, and then it went away. So let's go back to the level blueprint and take a closer look at print string. Notice that it has a drop-down, and we can click on that to expand it. So print string actually has more inputs than simply the inString input. And we can change some of the options on this node. We can change the text color. I can make it more red if I want to. I can change the duration. Rather than 2 seconds, maybe I'd like to see this message for 30 seconds. So I'm going to change the inString data to say 30-second debug message. Let's give this a try. Now, you may have noticed that from here in this Blueprint editor, we do have a play button, and we can simply press that play button from here. If that happens, we get a standalone window for the Pi session. And notice the 30-second debug message is sticking around. It's going to stick around for 30 seconds. and of course, its color has changed. Now we can press stop or we can simply close that window to end our Pi session. So our basic map level blueprint now has functionality. It's going to print a debug message to the screen. And again, this is made for development only. This is not text that we would show in an actual game, but print string is a useful tool that we can use to verify that some of our code is actually working. For instance, we've just proven to ourselves that begin play does execute at the beginning of the game. So in a sense, we've just debugged to make sure that begin play is working. So you can see why begin play would be so important, as any functionality that we want executed at the beginning of the game for the level blueprint will hook up those nodes here. Now beneath begin play, there's event tick. If we hover over it, it says event called every frame if ticking is enabled. So what does every frame mean? Well, as soon as we start a Pi session, we now have an image rendered to the screen, and as I look around, that image is changing based on where I'm looking. So we're really seeing a very rapidly changing series of images, and these images change every frame. We call it a frame when the image rendered to the screen changes, and it changes so rapidly it's really smooth. It looks like a video. I'm going to hit escape, and I'd like to print our message to the screen from the tick event. In other words, every frame. Now we can hold Alt and click on an input execution pin to break the wire. I'm going to go ahead and drag a new wire and connect it again to show you that we can also hold Alt and click on the output execution pin for a node, and that will also break the wire. I'm going to connect the wire once again and show you how we can take the beginning of the wire and move it over to this node. I'm going to hold Control. As soon as I hold Control, I can click and drag this wire all the way down to the output execution pin for event tick, and now event tick is connected to our print string. Let's see what happens with this blueprint logic. I'm going to press play, and notice that our message is spamming the screen. It's being printed every single frame. So that shows us that event tick is working. Now, if we don't want to spam the screen, we can use the key input. The key, if we hover over it, has the data type name. Now, this is similar to a string in that it's a series of characters. But under the hood, the string and the name have different operations that can be performed on them, and they're used in different scenarios. Now, we can change this key to anything else other than none, such as perhaps message 1. With no spaces. Something that you'll learn is that names are not designed to have spaces in them. They're more basic, used as identifiers, whereas strings can be any series of characters. So if we change the key to message 1, let's see what happens by pressing play. Notice we only see one message. That's because our message is using a specific key, and all messages using the same key will replace each other as soon as a new message is printed to the screen. So we are printing this message every single frame, but each new message is replacing the old message. Let's go back to the level blueprint and hit stop. And let's take a look at the output pin on the event tick called delta seconds. Delta seconds is a numerical value that tells us how many seconds have passed since the previous frame. Now, as we know, each frame is updated very rapidly, so this is going to be a very small number. But we can print that number with our print string. Now, we know that our in-string input has the data type string, and the delta seconds output parameter does not have that data type. Its data type is actually what we call a float. Floats are numerical values that have a decimal. So as opposed to whole numbers like 1 and 2, a float has a decimal component, such as 1.5 or 2.76. Now, let's see what happens if we take that output and drag its wire to the in-string input. Before I release, notice the pop-up says convert float, single precision, to string. And if I release, we have a new node connecting the green wire and the pink wire. This is what we call a conversion node. The Blueprint scripting system is smart enough to know that delta seconds and end string are two different data types, and it's going to convert from one to the other. So it's going to take that numerical value and represent it by a string of characters. And we can always move these nodes around to make our blueprints more organized. So now that we have a different value passed into end string, whereas before we were using a value that we typed into the text box, we call this hard coding a value in. Well, now we're passing a value in with a wire. We're getting the value from delta seconds. So let's see what this looks like in a Pi session. Now we see a numerical value. This is the value of delta seconds. For my computer, it's about 0.00833, and that last digit is changing. It looks like it's flipping between a 3 and a 4. And that's because from frame to frame, that delta seconds value is changing slightly. So the amount of time passing between frames is not constant. It's actually fluctuating between these two values. And depending on what you have going on in your game, that value can fluctuate even more. As you have lots of computationally expensive operations going on in your game, it may take the engine longer to perform those operations, and that can stall the game, slowing down the frame rate, resulting in what we often refer to as lag. I'm going to go ahead and close that window. So now we have experience with both begin play and event tick. And those nodes just existed here already. They were grayed out until we used them, but they were just here for our convenience. And if you take begin play, select it, and hit delete, you can actually remove that node. But no worries, you can always get it back by right-clicking and searching for it. We can search for begin play, and here it is, event begin play. We can get it right back, and we can use it. So we now have experience using the level blueprint, and we know how to fire off any type of scripting logic that we create by hooking up those nodes via wires to these events. Anything that we want performed at the beginning of the game in the level blueprint, we can hook up to begin play. And if we want something performed every single frame, we can hook it up to event tick. And we even have access to the amount of time that has passed since the last frame. And we also know how to print a debug message to the screen using the print string node. So congratulations, you've now made your first blueprint script. But don't worry, things are going to get a lot more exciting than printing strings. I'll see you in the next video.